And for the first run, we pull off enough cable for the entire distance, allowing plenty of extra for the connections at both ends. This one will go from the service panel to a switch box for the light. To get things started, we run one end of the cable down through the top plate, along the stud, past the front of the panel. Code requires that the cable be secured to the framing every 4.5 feet. These are special staples that hold the cable in place without damaging the conductors inside. Here we need two, one near the top plate and one near the panel. Next, we thread the cable through the holes in the ceiling joist, which gets us over the doorway. By the way, where the cable is supported by holes in the joist or the studs, no staples are necessary. Once past the door, we run the cable through the top plate down to the switch box, and we staple it as needed along the side of the stud. According to code, the last staple before the cable hits the box should be no more than 12 inches from the box to keep the cable properly confined.
The cable we've just run will bring power from the service panel over to the switch. The next cable will bring power from the switch over to the light. It goes along the same stud as the first cable and gets stapled into place. It's possible to staple one cable directly on top of another. It's also possible to leave all the cables loose and staple them all into place at the same time once the wiring's done. The overhead light is one joist over from where the cable comes up, so I have to run it through one more hole. I make the bend and run it along the side of the joist out to the fixture box. This is another situation where the cable needs to be supported at least every 4.5 feet.
Recessed lights like this generally hang between two ceiling joists suspended from a metal bar nailed or screwed into the bottom of the joist. They don't require a separate electrical box because they come with an attached metallic box where you make the electrical connections. And that should give you an idea of how to rough in electrical components when the framing's still open.
If you don't have access to open framing, you can put in what's known as a retrofit or remodeler's box and pull new cable through an existing wall. The first step is tracing the outline of the box on the wall so you can cut a properly shaped and sized hole. Just make sure you're going between the studs, not directly over one. You can use a keyhole saw to cut a hole like this in drywall, but to go through plaster and lath, you'll probably need to drill pilot holes and use a power saw like a jigsaw or reciprocating saw. In this project, there was an unfinished basement below, so we could drill up through the subfloor and bottom plate directly under the new box location. That's where the new cable will enter the wall cavity above. The next step is using a fish tape to bring the new cable up. It's actually a thin, flexible strip of steel that you fish into the new opening till it hits the bottom of the wall cavity, and then use like a probe to find the hole you drilled. You can't see where it's going, so it might take some trial and error before it finally pokes through. Once the end comes through, attach one end of the new cable to it. The other end goes back to the power source. Make sure it's fastened securely so it doesn't come loose inside the wall. Then from above, start rewinding the fish tape to pull the cable up. Take your time so it doesn't get hung up along the way. Once the cable's cleared the hole in the wall, you can detach it from the fish tape and run it through the back of your remodeler's box. To finish the rough-in job, you secure the box in the opening. The easiest one for do-it-yourselfers has flanges that catch the backside of the wall when you insert the box, and then lock it in place as you tighten the screw at the back of the box. That's one way to retrofit electrical boxes. Let's go back to the demonstration project to talk some more about working with new cable.
Now we want to cut the wires to their final length. Code requires that each wire extends 6 inches from the front of the box. This is called 6 inches of free conductor. I hold the cable next to the box and cut it to the right length. You'll find that these lineman's pliers are a useful tool in wiring. Next, I strip off the outer plastic sheathing. This little tool has a tiny tooth on the inside. I slide it up over the cable, squeeze it gently, and pull it down past the end of the cable. This splits open the sheathing. Now I peel it back and cut it off. To get the wires into the box, we have to break through small plastic holes on the top called knockout tabs. You punch through the tab with a screwdriver or handle of the pliers. Now I push the wires into the box. This box also has a metal cable clamp that will hold the wires in place. I fish the conductors past these.
Before attaching any devices, you want to expose about an inch of bare wire on the hot and neutral leads with a wire stripper. It has notches corresponding to the various wire sizes, so you set the wire in the right notch, squeeze down to cut the insulation, and hold tight while pulling the insulation off the end. That's a basic technique, but in new construction, you generally leave that step till the final trim out stage.
The trim out is the last step in a new electrical installation. You can see that all of our finish work is done. Now we can finally hook up all the switches, receptacles, light fixtures, and appliances. We've mounted the boxes properly because they're flush with the surface of the drywall, or a little behind it. Code allows the boxes to be recessed up to a 1/4 inch back from the drywall. This part of the job is pretty simple. Just consult your plan and hook up the appropriate device to each box and put on the cover plate. The color coding on the screws makes this pretty easy. If it isn't clear on the fixture you're dealing with, well, then there are other indications. The ground screw connects to the mounting strap. It's a hexagonal screw and it's often labeled with the letters GR. The hot side of an outlet is always on the side with the shorter slot on the face, and the neutral side always has the longer slot on the face.
To install an outlet, you simply connect the wires to the appropriate terminals. Remember now, these cables are not connected to any source of power, so they're safe to work with. If you ever need to work on powered cables, be sure to turn off the breakers for the affected circuits back at the service panel. Then use a circuit tester like this to make sure the power's off. It'll light up if the power's on. And it's not a bad idea to post a warning to keep everybody from flipping the breakers back on. After stripping the end, use a needle nose pliers to bend the wire into a small hook. Fit that around the screw itself and tighten the screw down. By the way, you get the surest connection if the hook goes clockwise to the screw. Follow that procedure for each of the leads and the ground. Once all the leads are connected, you can push the cables back into the box and secure the outlet to the box by driving in the screws attached to the mounting ears on the top and bottom. To wire a series of outlets, you sometimes see the incoming leads attached to one pair of brass and silver screws with the outgoing leads attached to the second pair. But electricians will generally use pigtails in a situation like that. They first separate the leads by color, twist each set together with a 6 to 8 inch wire of the same color, and then secure each set with a wire connector. These shorter pieces are the pigtails which get connected to the device. The most critical device in power in kitchens, bathrooms, basement, and garages is a GFCI receptacle, which stands for Ground Fault Circuit Interrupt. It'll cut power instantly if it senses a short circuit or other faults that would otherwise be quite dangerous. Here's how it works.
A GFI receptacle constantly monitors how much current is going out to a device on the hot lead and how much is coming back on the neutral. Normally, these two amounts of current are the same. In a fault situation, the dangerous current is the current that doesn't come back on the neutral. This current might be trying to return to ground through other routes, possibly through a person who's in contact with water. A GFI senses differences in current as small as 5/1000ths of an amp and shuts off the power within a 40th of a second. They're wired a little bit differently than regular outlets. Well, for one thing, they've got 2 extra screws. These hot and neutral screws are labeled line. This is where the incoming power is attached. Then these extra screws, labeled load, feed power out to the other outlets. Any outlets attached to the load side will also receive GFI protection from this device. So we'll wire this receptacle to the right side of the sink to the first GFI and get GFI protection without having to use a second GFI device.
Now we'll show you how to install a few different types of light fixtures, starting with what's known as a retrofit recessed light. It's similar to the rough-in model we put in before, but it goes in after you finish installing drywall and cabinets. Most come with a template to help you mark the opening you'll need to cut in the ceiling. The advantage here is you can position the lights exactly where you need them in relation to your countertops, islands, and other features. The trick is to run all the wiring you'll need during rough-in or figure out a way after the fact to get cabling into the joist space. Like the rough-in model, the retrofit lights come with a metal box where you make the necessary hot, neutral, and ground connections, twisting the wires and capping them with the appropriate connectors. The beauty of the retrofit unit is that it will fit up through the opening, with the tail going in first and the can following behind. To secure it, there'll be clips that push down against the top of the drywall, while the rim of the can locks in tight against the bottom of the drywall. Various trim kits are available to finish off recessed lights. They work on both the retrofit and